Hello, today's video is a follow-up from an example we went over in class on a one sample z-test. So the problem in front of you, kind of the work through we have, is a criminologist is interested in the number of crimes committed by U of A students with that fictitious data set, made it up, so don't think too much into it. The criminologist expects business students to be different from all undergraduate students at U of A. So when you're reading through this, you need to pay attention to kind of the directionality or lack thereof. So when I say that, the big part of this is we just expect a difference. We don't specify greater than, less than, we just expect difference. With that, the criminologist wants to reduce type 1 error and use a probability of 1%. So that means we want to be confident in what we're saying. And if we do find something, reduce the likelihood that it is by chance. So we're wrong in that situation of concluding, say that there is a statistically significant difference when there actually is not. So with that, if we start off here with our null hypothesis, we're just going to follow down. So our HO would be that there is no difference. They're the same. So it would look something like it. I'm going to abbreviate just for space and time. So the mean number of crimes committed by business is the same as our population of all students. So again, it's equality. We don't expect a difference at all. So we're good to go there. Now our research hypothesis, keep in mind, this is where I said we expect it to be different. We don't specify a direction. We just are expecting a difference at large. And that's what we're going to see if we can find support for or not. So here we expect the mean number of crimes committed by business students to be different. Again, keywords just saying different, not specifying a direction, to be different than all students, our population here. So with that, we already know then that we have a non-directional, and we also see that the 1%, so that's non-directional. And the 1% ends up meaning that we actually have to divide that in half to 0.05%, because if you think about what we're doing here, we're trying to find our obtained value compared to our critical value. So say we find a value that falls between our critical values. Since it's non-directional, if it falls anywhere in between, this is where we failed to reject our null hypothesis. If it falls beyond into the tails, that's when we can identify that there is a statistically significant difference. So if it's greater than our critical values, we can reject our null hypothesis in support of our research hypothesis. If it falls between, we fail to reject our null hypothesis there. So with that, we have our null hypothesis, we have our research hypothesis, we know it's non-directional, we know we're looking for the 1%, so that equates to the 99% if you're thinking about the z-table, which I'll pull up here in a second. The key part is, since we have a non-directional, when we look up in the table, it can be in either tails. It can be greater than or less than, so that's why you have to split it in half when it's non-directional. We're not specifying a specific direction. So with that, that means we would be looking for a value as close as we can to get to 995. And this is where I already know on the table it doesn't exist, but we'll get as close to that as possible. Keep in mind, if we had just the 1%, it would be the 0.990. So it would truly just give us 1% left over, and that would reflect a greater than or less than. But since we have a non-directional, we want to find that 0.9950. So when I open up the Blackboard, if I come across, we can see it starts to pick up in 2.5. And if I go across, you can see that 2.57 and 8 both outline and kind of box it in to even be a little more conservative. And if I use 2.58, we'll get it close to that itself. So we come back to the table, and our critical value here is 2.58. So here is where the 2.58, that would be the negative side, this would be the positive side, our obtained value. So when we use the formula and our information in the table of our mean and standard deviation, to reject the null hypothesis, we would need a value greater than plus minus 2.58. All right, so we have our critical value. Now let's get to our obtained value. And this is just putting in the numbers into our formula up here. So I'm going to leave it in black, and I'm going to go up here next to it. Yes, we're good. So from our formula, we have z equals our sample mean of 7.6 minus our population mean of 6.8. So that's our numerator. And then again, keep in mind our denominator is the standard error of the mean. So if you want to do that first, no problem with it. I've gone over it in class how to do it that way too. Oops, and I don't know what all I did there, but there we go. And back to the main screen. Sorry about that. But our denominator will look like the population standard deviation of 2.1 over the square root of our sample size of 1125. So I'm going to solve this downwards first. What I typically recommend, and I have a calculator up off the screen, I want to take the square root of 125. And that will give me, and I'll keep the numerator as the same, 7.6 minus 6.8, 2.1 over 33.54. Now I'm going to solve both the numerator and denominator at the same time. So for the numerator, you take 7.6 minus 6.8, which gives you 0.8 over 2.1 divided by 33.54, which gives you 0.06. Sorry if you hear my dogs moving things in the background right now. So now you take the 0.8 divided by 0.06, and you get 13.33. And now if you look at this compared to our critical value, so this is our obtained value. So obtained value, we get 13.33. So we have that done. And this is saying now, if we have this, I'm going to just scroll down and make another chart here. Again, I'm just drawing this out again. We have 2.58, 2.58, and our obtained value, so these are our critical values. Our obtained value here is 13.33. With that, we know it does not fall in this area. So we know it's beyond our critical value. So with that, we can reject our null hypothesis. So reject null. And we can find support for our research hypothesis that there is a difference. So with that, you can conclude, we can say we can reject our null hypothesis. And keep in mind, we use the 1%, so 99% with that as well. We can say that there is a statistically significant difference in our sample of business students and the mean number of crimes committed compared to the population of all U of A students crimes committed. That's the language you should use in terms of interpretation on the back end, and what you should see on the exam or any other homework of if you're missing points, it usually comes to that. So if there's any questions, feel free to reach out. If not, take care. Of course, this freezes on me. Close everything else out. And there we go.